Have you ever wondered how a simple sketch, just a few black lines on a page, could possibly be turned into a full-color, photorealistic image? I mean, it sounds like pure magic, right? But it's actually the core idea behind a truly revolutionary piece of AI research. So today, we're diving deep into the 2017 paper that made it happen, image-to-image translation with conditional adversarial networks, or as pretty much everyone calls it, pix-to-pix. This thing was a game changer. It totally flipped how we think about computer vision and really laid the groundwork for all the wild AI image generators we see everywhere now. But to really get why this paper was such a big deal, we got to rewind the clock a bit. Before 2017, the world of image manipulation was, well, it was a world of specialists. Think about it like this. If you wanted to colorize an old black and white photo, you needed one very specific hand-crafted algorithm for that. Wanted to create a map from a satellite picture? Nope. That required a completely different custom-built tool. Every single one of these tasks needed its own unique purpose-built machinery. It was just so complex, so fragmented, and honestly, super inefficient. But then the authors of the Pix-to-Pix paper had this key insight, and it's captured perfectly in this one line. They realized that even though all these applications seem totally different on the surface, the fundamental problem is always the same. You're just trying to predict a new set of pixels based on the pixels you started with. That's it. And that single elegant insight, it changes everything. Because if the problem is always the same, why on earth are we building dozens of different tools? Why not create one single general-purpose solution? And that was the huge idea behind Pix-to-Pix, to build a universal image translator. The way they framed this was just beautiful. They used an analogy to language. So just like you can translate the idea of a cat from the word in English to the word in French, they argued you can translate the visual representation of a scene from, say, an outline sketch into a full-color photo. It's all just translation. And that was the real breakthrough. The goal was to ditch the dozens of rigid, hand-engineered algorithms and instead build one single, flexible framework that could learn to do any of these translations just by seeing enough examples. So how'd they actually do it? Well, the engine running this whole thing is a type of AI called a conditional generative adversarial network, or a cGAN. Now, I know that sounds super complicated, but the core concept is actually this really cool, simple story about an artist and a critic. Just imagine a duel. Okay, on one side you have the generator. Think of it as a master art forger. Its job is to take an input, like our sketch of a handbag, and paint a fake photo that looks as real as humanly or AI-ly possible. On the other side, you have the discriminator. This is your world-class art critic. Its only job is to look at the forger's work and say, nope, that's a fake. Or, whoa, okay, that one actually looks real. So these two are locked in this constant battle, this adversarial loop. The artist makes a fake, the critic shoots it down. But the artist learns from that feedback and tries again, getting just a little bit better each time. They do this millions and millions of times. And eventually, the artist gets so good at creating fakes that the expert critic literally can't tell the difference anymore. At that exact moment, you know the artist has truly learned the translation. Okay, so that's the theory. But the truly stunning, jaw-dropping part of this paper is the results. The authors didn't just test their framework on one task. They threw the exact same model at a whole bunch of different problems, just to prove how versatile it was. And this is the iconic example, the one everyone remembers. On the left, a simple line drawing. On the right, the photorealistic handbag the model created. I mean, look at that. The texture, the lighting, all those subtle shifts in color. It learned all of that just from looking at data. But it didn't stop there. Here, the input is just a simple colored block map where, blue means window, red means brick, and so on. And the model translates that into this incredibly complex, realistic building facade. And look at this. Same framework, totally different problem. It can take an aerial photograph and translate it directly into a clean, accurate street map. It's just wild. It could even learn purely stylistic translations, like turning a photo taken during the day into a totally believable nighttime version, complete with glowing streetlights and lit-up windows. The sheer breadth of what this one single framework could do, it was absolutely astounding at the time. And that brings us to the paper's legacy, because the pictures themselves were incredible, yeah, but the impact went so much further. It truly started a revolution in the field. Now, this is so important. The authors released their code to the public. This wasn't just some academic paper locked away in a journal. It was a tool that people could use. Suddenly, artists, developers, and creative people all over the world started playing with it, pushing its limits, and dreaming up new uses. It just sparked this massive wave of creativity and innovation. When you look back, you can draw a direct line from Pix to the world of generative AI we're living in right now. It proved that one general learning-based approach could completely demolish all those old specialized tools. This core idea, this adversarial training for translating images, it became a fundamental building block for all the bigger, more powerful models that came after it. So the Pix paper taught us that with the right approach, AI could learn to translate between visual languages. And it leaves us with this incredible question to think about, from translating text to protein structures, or maybe even brainwaves into speech. What's the next language we're going to teach machines to translate? This is for entertainment purposes only.